Hey everyone, I'm back, and we're going to take a look at another phenomenon in the world of diffraction and interference, and we're going to take a look at that right now, so sit back and enjoy. I hope you remember our friend this apparatus from the previous video, where we looked at the double slits, and you'll recall that I shined a light right through that double slit, and we got that pattern. Well, over here, we do not have double slits, but believe it or not, if we could zoom in on that enough, and this picture is certainly not a good way to see it, we would see not double slits, not triple slits, but many, many, many slits going through the black plastic film. And I've tried to draw them there. That's pretty crude, but if you look here, we can imagine many, many, many slits, all very, very close together. And when we shine the light through that, we once again see evidence of the fact that light behaves like a wave. It diffracts and interferes, just like we saw with the double slit. So you'll recall the setup that we used last time. We've got the laser coming through, and this time going through the diffraction grating, those many, many slits, and it continues on to the wall. And I've provided a little suspense here for you. We're going to wait to see how it behaves when it reaches that wall. And there it is. We can see here where it's in contact with the wall, where the light strikes the wall. We have, much like we saw before, a set of bright spots and dark spots, but there is one key difference. Here, with the diffraction grating and the many, many, many slots instead of just two, we get far more defined bright and dark spots. We could still call them the 0th, the negative first, the positive first, the negative second, and so on. But I hope you notice they're much more defined than they were in the red. The dots really are like dots. And that is one of the great things about the diffraction grating, is it gives us such clearly defined locations. And just as we saw last time, with these bright and dark spots, we can imagine a straight line to where the diffraction grating was and is, and to each of these bright dots, there is an angular position where we set the m value, m equals 1 here, m equals, for example, negative 4 there. And there is an equation that describes the relationship between the angle, the m number, the wavelength, which is, of course, the color is associated with a wavelength, and the distance between the slits. This equation will look familiar because the equation is m lambda equals d sine theta. It's the same equation as for double slit. The only real difference here is d is the distance between the slits, and we assume that our diffraction grating has uniformly distributed slits. So the d is not just the distance between two slits, it's the distance between all of the slits. If there are 100 slits per centimeter, then the distance between slits is 0.01 centimeters. And that might be roughly appropriate for what we saw. We can have very, very close slits next to one another. One thing I should add to wrap up this video when we talk about diffraction gratings, earlier in the PDF I mentioned Rosalind Franklin and her work with the DNA structure using X-ray diffraction. I likened that to Young's double slit equation, but really it's much more like what we see here. Instead of having a diffraction grating of evenly spaced lines, Rosalind Franklin was working with DNA molecules crystallized with evenly spaced structures within the molecules, and those structures created the slits between them, and she was able to interpret the diffraction pattern that X-ray radiation left on some film to determine the distance between those structures, and with those distances, the structure of the greater DNA molecule is more easily understood. So that is a little historical reference, but one place where the idea of diffraction and interference gave us a way to measure something that might seem impossibly small to measure. Well, that is our diffraction interference discussion. Look for some problems on this, and it'll definitely be on the test on June 1st. So good luck.